Hi everyone, welcome to Cultrep. So let us execute our 120 days of preparation strategy. So in these 120 days, let us divide into 4 chunks, different weeks. In week 1 to week 8, let us concentrate on high priority subjects like electrical circuits, next power systems, electrical machines, power electronics and control systems. These 5 subjects we need to concentrate. So daily at least 1 hour practice the aptitude also. So now let us start with the power systems. So let us start with the power systems. So let me divide the power systems into 4 chunks like power systems basics and generation, and the next one is transmission and distribution. So power system analysis, and fourth one is the protection. Now let us explore one by one. So for example, if I take the power system basics, so in that, so AC circuit fundamentals, three-phase AC circuit fundamentals, so like different topics are there, right? I will cover everything in this. So in this total 120 degrees duration, 120 days duration. So now, so if I consider the single phase AC circuits, so now let us start our lecture with the single phase AC circuits. So here, what you need to observe, so I will take each question and I will explain the concept behind each question, so that the concepts will be covered as well as questions also will be covered, right? So now let us take the first question to explain the power AC circuit, single phase AC circuit fundamentals. I will take this question as the first question, right? So what is this question? So here, if you observe here, so what are the things that are mentioned in this question? So here, let us see V at an angle alpha. Voltage has mentioned. So V is given as V at an angle alpha, right? So I is given as I at an angle beta. These two things has given. So what they are asking, so what about the current situation, whether it is leading or lagging? So what is the condition for that between alpha and beta, and what is the polarity of the reactive power? So to understand that, so we need to go to the fundamentals. So first understand the concept and then apply it. The basic funda is, so first understand the concept and apply it. So first let us understand the concept. So what is given? Let me explain the concept first. After that, let me close that question. So now, so what are the things they have given? V at an angle alpha, I at an angle beta. So if I take sinusoidal waveform as a reference, so how can I write? So V equal to V into sine omega t plus alpha, right? I can write like this, right? The next one is I. So how I can write? I sine omega t plus beta, right? So here in this, it was mentioned as maximum value. First understand the basics. No need to confuse at all. Just understand the basics first. So here it was given as the maximum value. Maximum value is given as V. How can we find the RMS value? So RMS value equal to maximum value divided by root, right? VRMS. Similarly, IRMS equal to I max divided by root. Now let us find the power. So how can we find the complex power? So if I want to find the complex power, so I need to multiply the voltage and current. We know that. So the multiplication of voltage and current is power. So here V into I. But it is an AC power. One more condition also should satisfy. What is that condition? We need to keep the conjugate here. Power equal to V into conjugate of I, right? Why we need to keep the conjugate here? To satisfy the condition of the reactive power. What is the condition? So we are assuming, but to make the analysis, we are assuming reactive power of inductor is assumed as positive. That is, inductive reactive power inductive reactive power is positive. To make this condition true, we are making the conjugate of I. We are making the conjugate of I. So why? Let us see. For example, if I am not applying the conjugate, what will happen? So V into I. So that is V into I. So at an angle of alpha plus beta. At an angle of alpha plus beta. What is reactive power? So reactive power Q equal to Vi sin alpha plus beta. So what happens in some cases, it depends on beta and alpha, there may be possibility of inductive reactive power. Inductive reactive power is negative. And this condition is violated. This condition is violated. So we need to keep the conjugate of I here. We need to keep the conjugate of I because to make the inductive reactive power is positive assumption is true. So this is an assumption to start an analysis. Right? So now we are clear. So what is the inductive reactive power? Is positive. That is lagging reactive power is positive. Assume that lagging reactive power is positive. Now let us do the VI conjugate. So how we can do the VI conjugate? VRMS at an angle alpha. VRMS at an angle alpha into IRMS at an angle beta minus beta. Why? Because it is the complex conjugate of I. So we'll get the VI into at an angle of alpha minus beta. Now we got the alpha minus beta. Now, so let us apply the same concept here. So let us apply the same concept here. So what is the angle between these two? Or else you can make like this. Take one reference vector and then so V at an angle alpha, keep the V at an angle alpha and I at an angle beta. If you want to make that both the angles, it is alpha minus beta. Alpha minus beta. You can make like that. So now what we got? VI conjugate is equal to VI sin alpha minus beta. We got the reactive power is V into I into sin alpha minus beta. So as we know that apparent power is S, which is equal to V into I. So active power equal to Vi cos pi. Pi is an angle between voltage and current. So reactive power equal to V into I into sin pi. From that we have applied. Now let us see here which option is correct. Let us see which option is correct. So for example, if alpha minus beta, so alpha minus beta is greater than 0, which is equal to alpha is greater than beta. So what happens if alpha minus beta is greater than 0? So sine of something, sine of theta equal to, so sine theta, which is equal to reactive power equal to positive. So reactive power is greater than 0. In that case, reactive power is greater than 0. What, in which condition reactive power will be greater than 0? We are assumed. When will be the reactive power is positive? When it is inductive reactive power. That is lagging reactive power. So current, which is inductive, so which means current lags. In inductive load, current lags the voltage. Current lags. Right? So on the second condition, when beta is greater than alpha. When beta is greater than alpha, what happens when beta is greater than alpha? So when beta is greater than alpha, so alpha minus beta is less than 0. When alpha minus beta is less than 0, the reactive power is negative because sine of minus theta equal to minus sine theta. So Q is negative. When will be the Q is negative? When it is capacitive. When Q is positive, we are assumed that when Q is positive, it relates to the inductive power. When Q is negative, it relates to the capacitive power. So very simple, right? Current leads. So now let us check. See B and C options. Current leading the voltage when beta is greater than alpha. When beta is greater than alpha, current leads the voltage and the reactive power is negative. Reactive power is negative. So on the C option, current is lagging when alpha is greater than beta. When alpha is greater than beta, current lags and the reactive power is positive. And these two options are right. So both C, B and C are correct. So now let us see the next problem. Let us solve our second problem. So from this problem, you need to understand the concepts of what is active power, what is reactive power, and what is apparent power, and how these powers can be calculated, on which factors these power will be depends, and everything will be concluded. See here. So, and this is the problem that was given. So, in this, VAN and IAN has given. So, what is VAN? So, first understand the problem. So, what is VAN? So, VAN is given as V max sin cos omega t. VAN is given as V max cos omega t. Right? And IAN given as I max into cos omega t minus theta. IAN equal to I max into cos omega t minus theta. Cos omega t minus theta. So now, let us find. So let us find. So VAN into IR and VAN into IX. What is VAN into IR? For example, it is VAN into IR is the power across the resistance, which is active power. VAN into IX, so that is reactive power. So indirectly, we need to find the active power and the reactive power. So what are the things they have given? VAN and IAN. So we need to find the active power and reactive power. So let me solve the problem. So VAN equal to V max into cos omega t. Right? So IAN is given as I max into cos omega t minus theta. Now we need to find the power. So let us find the instantaneous power. So here, so directly with the expression, let us find P of t equal to instantaneous power equal to. So let me write this Vmax equal to root 2 into Vrms. So root 2 into Vrms. That V is the Vrms into cos omega t. Right? Into root 2 into IRMS into cos omega t minus theta. How can we solve this one? So which is equal to V into I into 2 cos omega t into cos omega t minus theta. What is the formula for the 2 cos? 2 cos theta 1 into cos theta 2 equal to cos theta 1 plus theta 2 plus cos theta 1 minus theta 2. If I apply that one, so which is equal to theta 1 minus theta 2 equal to omega t minus theta, which is equal to Vi cos theta plus Vi into cos theta 1 plus theta 2. Theta 1 is omega t, theta 2 is the omega t minus theta. So if I write the equation for that, so which is equal to Vi into 2 omega t minus theta. Now cos 2 omega t minus theta. Now apply cos A minus B formula. That is cos A minus B equal to cos A cos B plus sin A sin B. Very simple, a simple mathematics. So which is equal to cos A cos B, that is cos 2 omega t into cos theta plus sin 2 omega t into sin theta. If I write the expression which is equal to V into I into cos theta plus so cos theta into 1 plus cos 2 omega t 1 plus cos 2 omega t 1 plus cos 2 omega t plus Vi into sin 2 omega t into sin theta. So which is equal to Vi sin theta into sin 2 omega into sin 2 omega. So observe this equation, which is very important. Observe this equation very clearly. So which is equal to what is VA cos theta? VA cos theta, which is an active power component, right? Active power component. So VI cos theta and this total term related to the active power and this total term related to the reactive power. So now, from this we can answer the question, but we need to draw the conclusions. So what are those conclusions? This Vi I can write as Vm by root 2 and Im by root 2, right? So which is equal to Vm Im by 2. So the similar expression I wrote here, Vm Im by 2 into cos theta into 1 plus cos 2 omega t, Vm Im by 2 into sin theta into sin 2 omega t. So which is active power component and is the reactive power component. Now let us see what is active power. What is active power? So the active power has an average value of VA cos theta or VA cos pi. So it is here, it was mentioned as theta, right? VI sin VA cos theta and has the frequency of twice the supply frequency. Let me write here. So here I can write this active power definition as active power is the power. Active power has average power of, what is the average power? If you observe here, so which is equal to VA cos theta plus, if I write this expression, what is VI VRMS into IRMS into cos theta into or plus VI cos 2 omega t. VI cos theta into cos 2 omega t. Right? Which is an expression for active power. So if you observe here, if I find the average value, what is the average value of this one? If I find for this one, because it has the cos function, so the average value is 0. Average value is 0. For example, if I find this one, what is the average value? So which is then equal to average. Right? So what is the active power? Active power has an average power. Active power has an average power of Vi cos theta. Active power has average power of, which is very important, Vi cos theta with the twice the frequency. Here what is the frequency? It is cos 2 omega t, 2 times of the fundamental frequency. So which has the 2 times of or twice the supply frequency. Twice the supply frequency. So, and it is a unidirectional power. So for example, what is the theta range? How can we define the theta range? Theta is power factor angle, it depends on the load. So what are the loads we have? Either inductive load or capacitive load. So in case of inductive loads, lagging power factor, and in case of capacitive loads, leading power factor. So what is the theta range? The theta range is in between minus 90 to 90 degrees. Right? Minus 90 to 90 degrees. If I apply minus 90 to 90 degrees, what happens? This is always positive. What does it mean? So the active power is always positive, which is a unidirectional power. Which is unidirectional power. Unidirectional power. Unidirectional power. So here we define the active power. What is an active power? Active power, very simple. Active power has an average value of Vi cos theta or Vi cos pi and has the frequency of twice the frequency of 2 times of the supply frequency, and it is a unidirectional power. So for the theta in between the minus 90 to 90 degrees. So which is the definition of the active power, which is actual definition of active power, so which is derived from this expression. Now this expression is important. Note down this expression, and this expression is important. Now let us see the most complicated to understand is reactive power. So reactive power, which doesn't have any work done. So let us see what is reactive power also. So reactive power. So what is reactive power? Let us see what is reactive power. What is the expression for reactive power we got? Reactive power equal to Vm Im by 2 sin pi or sin theta into sin 2 omega. Sin 2 omega, which is a constant, that is Vi sin theta. In RMS value, if I write in the RMS, which is equal to Vi sin theta into sin 2 omega. Sin 2 omega. Now, if I find the average value of this expression, what will be the average value? The average value is 0. The average value is 0. What does that mean? So if I draw this one, for example, if I draw this one, let us see how the reactive power will be. If I draw the reactive power, how can I draw the reactive power? So if I draw the reactive power, so which is sin 2 omega t. For example, if supply voltage has this one, let's assume that sinusoidal, and the reactive power should be 2 times of the supply frequency. 2 times of the supply frequency. If I draw approximately 2 times of the supply frequency. So it is having the maximum value of Vi sin theta. Vi sin theta. If I find the average value, what is the average value? So here the average value is 0. If I take one cycle, the positive cycle area equal negative cycle area. So average reactive power is 0. Reactive power is 0. Now how can we define the reactive power now? So reactive power doesn't have any average power. It's just exchange the power between the source and load. So which is called as oscillating power. The reactive power is also called as, so reactive power definition is reactive power is also called as oscillating power. Oscillating power. And it has the average value of 0. And it has the average value of 0. Average value of 0. And it has a frequency of twice the frequency of 2 times of the supply frequency. 2 times of the supply frequency. Reactive power has the frequency of 2 times of supply frequency. Now, what is the active power? What is the reactive power? So, active power is an actual power or average power. It has an average power of Vi cos theta, and it is a unidirectional power. It is the power, it has the frequency of twice the supply frequency. If I take the reactive power, So what is the reactive power? Reactive power is an oscillating power. So the power will oscillate from source to the load and load to the source. So from source to the load, if Q is positive, so from it supplies to the load, so source is supplied to the load, and in the reverse side when Q is negative, so load to source. So it is oscillating between the source and load. Very simple. It has the frequency of 2 times of the fundamental frequency. So this is the concept, and we are getting the questions frequently from this concept. So now let me explain you. I will take 2 more minutes and I will explain you. So what is the VA? So for example, this white waveform is the voltage, which is equal to Vm cos omega t. Vm cos omega t. Now this yellow color is current waveform. What is the magnitude of current waveform? Vm cos omega t minus theta. Cos omega t minus theta. Now, so if you draw the voltage waveform and current waveform like this. So for example, if you draw for the reactive power. So how the reactive power? Vm Vi into sin pi into sin 2 omega t. So it has the 2 times of the supply frequency. If I draw the active power will be like this. What is the expression? Vi cos pi into 1 plus cos 2 omega t. So 1 plus cos 2 omega t, if I draw like, it will be like this. It is unidirectional. It doesn't negative. It doesn't be negative. It is always positive and it is unidirectional. So now, let me tell you one more thing and I will close this one, right? For example, now let us answer this question. So what is the answer for this? So more than answering this question, finding the concepts is important. What are those concepts? We have learned about what is an active power, what is a reactive power, so what is an apparent power, and so why it is called as an oscillating power, and everything we have learned through this equation, right? So now what is the answer? So Vm in by 2 cos theta into 1 plus cos 2 omega t is an active power. And Vm by 2 into sin theta into sin 2 omega t. So it is a reactive power. We got this. So option A is the right option. For example, now same circuit has given VAN is, if VAN is given as, in the same circuit, if VAN is given as Vmax sin omega t. Before that it is cos omega t, right? In that problem. Now it was given as sin omega t. IAN is given as Vmax into sin omega t minus theta. So in the similar manner, so which is Imax into sin omega t minus. Now derivation is similar. So let me write the expression directly. So P of t equal to, so in that same manner, VRMS into IRMS into cos theta, here it will be the 1 minus cos 2 omega. 1 minus cos 2 omega minus Vi sin theta into sin 2 omega. In case if the problem is modified, so you can answer this one. In both the cases, if you observe here, in both the cases, the definition has not changed. So it has an average value of Vi cos theta and it has the frequency of twice the supply frequency. It has an average value of The reactive power has an average value of Vx sine theta, not average value of 0, and it has the peak value of Va sine theta, and it has the frequency of 2 times of the fundamental frequency. So now let us solve the applications of AC circuits. So AC single phase circuits. So let us solve the different problems so we can understand concept even more clear. So now let us solve some problems related to the active power and reactive power. So now let us take the first question. So in this question, it was mentioned that voltage is given as 10 sine omega t minus pi by 6. First we need to observe that in this type of questions, so whether both are referred to the sine wave or not. Both waveforms have the same frequency or not. Yes. So it has the omega frequency, it is also omega frequency. So we can proceed. 10 at an angle minus pi by 6, right? So the current is given as 10 at an angle of plus pi by 6. So if I want to find the power, so what I need to do? So I need to calculate it is VI conjugate. V into conjugate of pi. So the power equal to, so in case of this, so this type of voltage and current given, so we need to calculate the complex power, so which is equal to V into I conjugate. So if I want to find the complex power, so I need to take the V RMS and I RMS. So here it was the V maximum. So what is the RMS value? So maximum value divided by root 2. So at an angle of minus pi by 6 is nothing but, so minus pi by 6 is 180 by 6, which is equal to minus 30 degrees into, so 10 by root 2 into cos into 30 degrees. Both are 10, right? So if I multiply both, so 100 by 2 at an angle of, so this is a complex conjugate, so I can write this as also minus, right? So minus 60 degrees. So now if I want to find the power consumed, what is the power consumed? So the consumed power is an active power always. The consumed power is an active power. So power consumed equal to P equal to VI. So already we got the VI as 100 by 2 into cos pi is cos 60 degrees. So what is the cos 60 value? So 1 by 2, which is 100 by 4, and which is equal to 25 watts. So the answer is 25 watts. So next solve the next question. So in a circuit, the voltage and current are given by the V equal to 10 plus J5 and I equal to 6 plus J4. V equal to 10 plus J5 and I equal to 6 plus J4. So now what we need to find here? So these two are given in the rectangle components. That is no problem. So we need to find active power and reactive power, and whether it is capacitive, inductive or resistive we need to find. How could we find? So as we know that first we need to find the active power and reactive power, and then we should observe that we got the reactive power as negative or positive. If it is positive, it is inductive in nature. If it is negative, it is capacitive in nature. Very simple, right? Now we need to find the voltage into current. So VI conjugate. Let us find the VI conjugate. What is that? 10 plus J5 into 6 minus J4. So conjugate of 6 plus J4 equal to 6 minus J4. Now multiply both. 10 into 6, 60 minus J40. So J30. So J square equal to minus 1 minus of minus plus 20. So 80 minus J10. 80 minus J10. So in that active power equal to 80 watts. And the reactive power equal to, so which is equal to S, apparent power, right? So reactive power equal to minus 10 VAR. Minus 10 VAR. Now, so in this option D is the correct. So in this option D is the correct. And what we need to find, whether it is capacitive or inductive. If it is like this, we can interact. But so what is the nature of the load? So because we got the reactive power as negative and it is the capacitive in nature. So option D. Simple, right? Next one. So here the two circuits has given, and if you find, spot the difference first. So voltage is given, capacitance is given, capacitance is given. The current direction is in this direction, so current direction is in this direction. So if we assume one convention, we should assume, right? If the current is leaving from the positive terminal, let us assume this as a positive current. So if it is entering into the positive terminal, let us assume that it is a negative current. So what is the general capacitance? So if I draw the voltage and current, so voltage and current, the current leads voltage by 90 degrees. So in case of capacitive loads, the current leads voltage by 90 degrees. So the first one is, the figure A represents current leads, I leads V by 90 degrees. So and what is the second one? The current is negative. So negative in the sense, so it should be in the opposite direction. So the current lags the voltage by 90 degrees. I lags V by 90 degrees. So 1 and 4 both are correct. So answer is C. Answer is C. So now let us see the next problem. So now let us solve the next problem. So let us see. So let us understand the problem statement first. So what is the problem statement? There is a single phase inductive load. So draws a 10 megawatts at 0.6 pf lagging. The reactive power of capacitor is connected across the load. To raise the power factor is 0.8. So from this, one thing we need to observe. So to raise the power factor, so we can connect the capacitor at the load, right? So now, let us understand the concept first. So what is an apparent power? So if I draw an apparent power, let it be the, so let us draw this is an active power, and the reactive power is, let me represent with the QL, inductive reactive power, and this triangle is the power triangle S. This is very fundamental, right? So the angle is theta. Let me call this as a theta 1. Theta. Now there is an inductive load in the circuit. The load in a single phase circuit, the load is in inductive nature. Now we just want to improve the power factor. So for that, what we need to do? So we need to compensate the inductive reactive power by connecting the capacitor to it. So now if I connect the capacitor, QC, which is having the, if I connect the capacitor having the value of QC, what happens? The resultant reactive power is QL minus QC. The resultant reactive power is QL minus QC. The resultant reactive power is QL minus QC. If I draw the resultant, it will be somewhere here. Let us assume that it will be somewhere here. So which is the magnitude of QL minus QC. That is inductive reactive power minus capacitive reactive power. So now If I draw the resultant for the same active power, so what happens? So let it be the S2. The theta 2 angle will be like this. So the theta 2 has reduced from theta 1 to theta 2, from theta 1 to theta 2. It has reduced, the power factor angle has reduced. If the power factor angle has reduced, the cos theta also reduces. Cos theta improves, right? So cos theta improves. If the power factor angle in a cosine, so cosine term, if the angle reduces, the power factor improves. So now, so if I want to operate, now it is operating, initially it is operating in the lagging power factor because it is connected as a lagging reactive power. Now I just want to operate this in the unity power factor. So what is the unity power factor? I had to bring down this QL to the 0. That means to operate the system in unity power factor, at unity power factor. So what we should do? We should compensate the inductive reactive power. So the magnitude of capacitive reactive power with the same magnitude of the inductive reactive power. So that means QL is equal to QC. QL equal to QC. If I can supply the capacitive reactive power which is equal to inductive reactive power, the power factor becomes a unity. So power factor improves. So there is an improvement of the power factor when I connect the capacitor across the load. Right? So this is one of the compensation technique which we can study in the transmission and distribution also. But let us understand the basics from here. Now, let us solve this problem. So in APTRANSCO and state PSCs, the calculator is not allowed. So that you need to remember some things. So right, for example, if the power factor angle is 36.86, power factor is 0.8, sin pi is 0.6 and tan pi is 0.75. So if the power factor is 53.13, so cos pi is 0.6, sin pi is 0.8 and tan pi is 1.33. Like that you need to remember some of the, just remember these things, right? So for example, to solve this problem, let us see what is the load power. It is 10 megawatts. Let me draw the P here. So what is the P value it was given? It was given as 10 megawatts. Now, so what is the power factor it is? So it is drawing the lagging power factor, that is inductive load, so which is equal to 0.6. So if I draw the power triangle, so let me assume this as a QL and let it be the S. So now, so what is the power factor angle it was given? The theta 1 is given as 0.6 power factor lagging. 0.6 power factor lagging means, so the theta 1 is the 53.13. Right? So cos inverse of 0.6 is the 53.13. Now, so we need to find the QL value. Let us find the QL also. How can we find the QL? So QL we can find as tan theta equal to QL divided by P, and theta 1 equal to QL divided by P. So QL divided by P. So how can we find it? Tan theta 1 is equal to, so 1.33. So P value is the 10. So from that QL equal to 13.33, which is in megawatts. So QL equal to 13.333 megawatts. So now we got the QL. So now, so we need to improve the power factor to the 0.85 lagging. So what is the 0.85 lagging? So for example, if I want to improve the power factor to the 0.85 lagging, so what is the angle? 31.78, which is less than the 53.13. The theta 2, which is equal to theta 2 equal to cos inverse of 0.85. So which is equal to 31.78. 31.7. Now, so we need to find the QC. So QC value, so we need to find. So to get this 31.3, 31.78, how much QC should be given? So which is equal to QC. And this is the QL minus QC. Right? So what is the value? So again, consider this triangle. Consider this triangle. Now consider this triangle. What is the tan theta 2? Tan 31.78 is the 0.619. So tan theta 2 is the 31.78, which is equal to QL minus QC divided by 10 megawatt. So what is the value? So which is equal to 6.19, 0.619, so which is equal to 6.19. So from this QC equal to 13.33 minus 6.19. How much we need to inject? So 7 minus 7.13. 7.13 MVAR. QC equal. But QC is negative. When compared to the QL, it is negative. So we can call it as this. Option A is the right option. Option A is the right option. So now let us solve the next problem. So the problem is stated as pure inductive circuit takes reactive power from the AC line when both applied voltage and current are rise and both applied voltage and current are decreases. Applied voltage increases, current decreases, and both A and B. So now, if you want to find pure inductive circuit, so if you take the pure inductive circuit, so for example, what is the pure inductive circuit? So V is given as, let me take V as Vm sin omega t, and I is taken as Im sin omega t minus 90 degrees. Because it is a pure inductive load, so what happens? So the current lags the voltage by 90 degrees. Let me draw both of this. So V equal to Vm sin omega t. So V equal to Vm sin omega t. I will lag the V by 90 degrees. Let it be the 90 degrees. So I lags V by 90 degrees. Let me represent with other color. So the current will be like this. So this yellow color line is voltage and this white color line is current. Simple. In case of pure inductive load, the voltage is yellow color line, which is equal to Vm sin omega t. The current lags the voltage by 90 degrees, so that it represented with the line, white line, and it is started after the voltage started at 90 degrees. Now, if I find the reactive power, so as we derived earlier, so which is equal to Vm Im by 2 into sin phi or sin 90 into sin 2 omega t. So it has a double frequency, right? So fundamental frequency is omega. It has the frequency of 2 omega. Now, if I draw the, and it has the negative sign. In case of this one, it has the negative sign. If you derive the formula, so you can understand. So for example, if you see here, you derive, so here P equal to, if both are sinusoidal waveforms, so Vm by 2 cos pi into 1 minus cos 2 omega t plus minus Vm by 2 sin pi into sin 2 omega t. So when pi is 90 degrees, so the active power equal to 0, it has only the reactive power and the negative sign is also there. So when we consider the sine waveform, when we consider both are sine, so it is minus Vm by 2 sin 90 into sin 2 omega t. So how this waveform would be? So it would be like this. Next, at this point, so it will be like this. Right? So this is the reactive power waveform. This is the reactive power waveform. So now, if I want to find the reactive power, how can I find? So it has to be takes from power from the supply. So I need to consider the reactive power value is positive. The reactive power value is positive. Now we should analyze these regions. So this region and this region. So now in this case, from 90 to 180 degrees, the voltage is falling and the current is rising. Voltage is falling and the current is rising. Again, Q is positive. In the second condition, what happens? The voltage is rising and the current is falling. Voltage is rising and the current is falling. So now we can answer now. So when Q is positive, the inductor takes the reactive power from the supply. So during that condition, so there will be two conditions are there. So when voltage is falling and current is rising, in the second case, voltage is rising and current is falling. So in the three options, in case of option 3, so the applied voltage increases and the current decreases, it takes reactive power from the AC line. So option C is the right answer. So if you know the concept, you can solve it in less than a minute. But so to explain the concept, I took all these terms, right? So after completing the lecture, I will upload this lecture in the Telegram channel. I will mention the Telegram channel in the YouTube caption. And if you have any doubt, you can keep it in the Telegram channel. I can make it a short, or I can make it in a Telugu video, or I can make it a main YouTube video. So you can, whatever be the doubt you have, so you can approach to the Telegram channel. I will mention the Telegram channel link, and you can approach to the Instagram link also. You can follow the Instagram. So you can approach the Telegram channel, and daily videos will be uploaded. 2 to 3 videos will be uploaded. I will take syllabus step by step. Now we took the AC fundamentals, right? So after that, whatever be the remaining questions left, here I will solve the remaining questions in the next session, as well as in the next section we will solve the 3-phase circuits as well as per unit quantities. And in case of power electronics, tomorrow we will take the DC to DC converters. So in case of machines, I will start up with the basics of rotating machines and transformers. So in case of control systems, I will start with the block diagram reduction and transfer function. So first in the 8 weeks, we will solve and we will give the priority to the 5 subjects, and those 5 subjects are power systems, machines, control systems, electrical circuits and power electronics. So after 8 weeks, let us concentrate on the remaining subjects. So let us divide all these 120 days into 4 chunks, give time for revision, give time for mock test, and prepare well. So if you have any doubt, you can contact me. Thanks for attending the session.